Hello, and welcome to today's webcast, VERITAS NetBackup. Is this a net backup or network issue? How to pinpoint and address the issues. My name is Danielle Moore, Marketing Manager at Datalink, and I will be your moderator today. Before we begin, I wanted to cover a few housekeeping items. This webcast is designed to be interactive between you and the presenters. The webcast console you are looking at can be completely customized. You can resize or move any of the windows that you have open. At the bottom of your audience console are multiple application widgets you can use. If you have any questions during the webcast, you can click Q&A at the bottom and submit your question. All questions from this webcast will be captured. If you are experiencing any technical difficulties, please visit the webcast help guide by clicking on the question mark icon below the presentation window. The help guide covers common technical issues. I would now like to turn this presentation over to our presenter, Paul Weaver. Paul, the floor is yours.
All right, thanks Danielle, and welcome everybody. We have a lot to cover today because I know this is a very deep subject that we can cover and can really take probably a good week to get through everything. So hopefully I will give you enough of an understanding if you don't have it, or some tools that you can use and things to do that will help make NetBackup work well with your network. So let's get started. Okay, for a quick overview of what we're going to be talking about today is essentially how the networks impact NetBackup, or how NetBackup impacts the network, depending upon your point of view. Cover some best practice tips and the effect of traffic transports and bottlenecks, understanding performance considerations. We'll cover some of the common status codes and some of the more frequent resolutions for them, and as well as common tools to help maintain or troubleshoot when there is a network issue that is happening. So to get started, this is a quote from one of the guys that I work with. NetBackup is the most robust network analysis tool that you will find. And why? Because it touches almost every part of the network, and in some cases it may be the biggest user of the network. And that is definitely true during times of like full backups and things like that, unless you're running some kind of video service or something like that. But how does the network impact NetBackup? As you can definitely tell, the first part of the application name is net, as in network. So it does have a, or the two are very tightly integrated. Here is a quick overview of where the network lies in relation to the NetBackup applications, whether it's running on the master server or on the client. You can see in this diagram that the NetBackup application layer sits on top of the operating system, which also has the device driver, and then the NIC, and then the connection to the network. So all of these are integrated, and if there's a hiccup in any part of this, it typically results in an error within NetBackup. Now, for most of us on this call, I have in the middle the mysterious network, because typically as backup admins, unless you're in a smaller size company, you don't have that view into the network. You're not the network administrator, and you don't necessarily have the tools that they do to know that the health of the network. So oftentimes that appears as a very mysterious part, yet a very critical part of the backup process. This is another example of what I just said. This being the Golden Gate Bridge, you can think of the bridge as your network connection, and traffic goes over the bridge and then off into the clouds. Where does it go? You have an idea, but you can't tell whether there's congestion or traffic is very light or there's repairs going on. Typically, from the backup application standpoint, we don't have that view into the network. Speaking of roads, this is the way I like to see it. The network is like a system of roads that a logistic company uses to transport goods, or if you're driving your car to wherever you're going. If something happens to the road, most of the time it's not the vehicles on the road that are the problem. It's something, whether the road cracks or breaks or is under construction, as the picture indicates. There may be maintenance going on the road that impacts the traffic going over it. And you might have to route around that construction from this perspective. But most of the time it's not the vehicle's fault that the road is broken, unless there might be an accident or of some kind. And then there's also the question, well, if you're trying to send semis over a 2-lane country road, is that the right path? Do you need a bigger road? Do you need to route traffic accordingly so that the road can handle the traffic that you're doing, that you're sending over it? Which is exactly what you can see here in this picture. Do you have enough lanes for the traffic to handle at rush hour? You might have a need for a 2-lane road during the day, but if you need a 6-lane road at times of rush hour or in times of full backups, in this case, do you have the capacity to do that? And what is the traffic flow when those things occur? Now, this is an example network layout. Most of us have this kind of understanding, but NetBackup, sits on a network and interacts with other things, whether it's through a firewall or with to some kind of server in the DMZ, or whether it's a file server on another subnet or an application server, or you're doing replications across a WAN to a remote data center. NetBackup touches typically every part of the network. So what are some things that we can do for traffic control or routing problems? One way that is typically used is adding a backup network. So you get your production traffic off of the, or you get your backup traffic, I should say, off of the network that your production traffic is running on. That way they don't interfere with each other. Typically that requires more NICs, sometimes more switches, and other networking gear. But it is an effective way to separate traffic if that is needed. Now, one thing that is typical with multiple NICs, and we'll kind of touch on this a little bit coming up, but NetBackup depends on the routing tables of the operating system. If the operating system routing tables can't route the packets accordingly, there's going to be problems, obviously. But that is not at the NetBackup layer. That's actually at the operating system layer. And so in order to get those correct, proper name resolution has to be used. Whether it's host files or DNS, those are key components of what this is, or what is needed. VLANs are another option that are becoming more and more popular these days, and this allows you to take the same network connections and create virtual LANs to separate the traffic. Now, VLANs are great at using what's already there, and they're also great in reducing traffic because there's a lot of broadcast traffic and extra chatter outside of backups and restores that are going on over a network or whatever other type of connection. There's a lot of chatter, and VLANs help to limit that chatter so as it won't affect necessarily a backup server versus your production network. Now, one thing to consider, though, is how many VLANs you have over an interface. If you're doing network bonding and you've got a large pipe, having multiple VLANs, having 8 or 10 VLANs over one interface, it may not be an issue. But if you're putting 10 VLANs over a 1 gig NIC and expecting to do, full capacity on each, that will most likely still be a problem. Another option to get backup traffic off of the production network is SANs. If you can do SAN-based backups, whether it's VMware or Hyper-V backups or NDMP or snapshot, I should say, based backups, that one offloads from the production network, but also helps to offload from the application servers that are using them and allows the backup hosts or the media servers to do more work. Now, you have to have the resources for those media servers to do that work, but that does help free up the resources on the front end. So SANs are a great option to get backup traffic off of the production network. Most of us already know that, but these are just things that we're reviewing as a, we either need to do that or plan that, or that is an option. Now, before we get into the rest of it, I'm just going to highlight a couple of best practices for addressing challenges. There are many different best practices within NetBackup, and I'm just going to cover a few that relate to the network side. There are more as you dive in, but to keep this under a multi-day presentation, I'm just going to cover some of the highlights. And those are first one is teamwork. What can we do from a backup perspective? Oftentimes, we at Datalink are working, when we work with y'all, there may not be that view into the network because your company may be large enough to have a separate network team and a separate server team and backup team. One of the keys to network troubleshooting is teamwork, being able to work with, members of each team. It sounds kind of silly almost, but oftentimes that can go a long way to identifying an issue very quickly if the other team members are all working together. Second point here is know your environment. This goes along with teamwork. Having a better understanding of what you're backing up, where it's located, how it's getting to the NetBackup servers, helps identify the bottlenecks. So if you're pushing a terabyte of data over a 1 gig NIC, that will typically be a bottleneck these days because usually there's enough CPU and memory, and disk speeds are fast enough that the network would be the bottleneck. So if you know where the bottlenecks are in your network ahead of time, it helps to identify what's going on when there is an issue. And that leads to know your tools. I've broken this out in two points. One is reporting and monitoring. A lot of times network teams already have implemented some kind of network monitoring, whether it's at the switch level or it's an appliance that sits on the network monitoring, that they have graphs and charts and everything to know the state of the network. It's good as a backup administrator, and this is where teamwork can also come in, to either have access to those to check on yourself or maybe get a report on the network health, so you know what's going on. Again, because if something happens to the road, the traffic going over that road will either be congested or halted. And if something does happen, knowing your tools ahead of time helps greatly. Now, what we're going to do on this presentation towards the end is to highlight some of the tools that we can use to help identify issues and know the bandwidth and the throughputs and stuff like that. We're not going to go in depth, but this kind of gives you a broad overview of tools that you can use to troubleshoot that, so when something does come up, you can easily and quickly attack the issue. Now, to speak to some of the more practical things of best practices from a backup perspective, one, with 10 gig NICs and 10 gig networks being more commonplace these days, enabling jumbo frames is one thing that you can implement at the operating system layer and on the network to better move traffic. You can think of it as, using a semi to transport your data versus a small moving van, as an example. Second point, again, is leveraging VLANs. VLANs, again, are good at segregating traffic, and which is a big deal in the security world, but it does also help with the backup world. So that is something that is definitely done, and especially when implementing network bonding. As we'll cover a little bit later, it also depends upon the kind of network bonding, but these are things that you can do from a best practice standpoint to make sure you're getting the best throughput over the network. So how does NetBackup communicate? It uses TCP versus UDP or some other kind of protocol. And these days, since the TCP IP stacks have been out for so long, most OSs have robust TCP stacks tuned for the majority of traffic. And then whether you load like a server edition or a data center edition, if you're thinking Windows, or operating systems of that caliber, they tend to be adjusted accordingly as well. Many years ago, and with older operating systems, when the TCP stack was not as robust, NetBackup offered what is, or this setting, the net buffer size or the buffer size setting on Windows, as an opportunity for NetBackup to tell the operating system how big to make these buffers. But these days, with the TCP stacks being as robust as they are, letting them do their job is a best practice versus having NetBackup try to tell it. And to do that, the best thing to do is to put either a 0 in the net buffer size file if you're on a Linux or Unix server, or to edit the registry buffer size, as you can see there. The TechNote link that you see on the screen, we'll talk more about it, and that's from VERITAS. It goes into a lot more depth. But the reason we have these here versus a GUI is typically, or at least in current versions of the GUI, of the NetBackup GUI, setting it to 0 is not an option. It doesn't go that low. However, that is a best practice. Also with TCP, VERITAS has noticed that as networks are getting faster and more is happening, at least with the Linux servers or Unix servers, there is what's known as a ring buffer for the network. The diagram that you see is, again, oversimplified process of this, and it actually goes both ways. But when traffic comes in over the NIC, the ring buffer doesn't contain the packets, it contains descriptors to the packets. And if there are not enough descriptors, you can think of them like file descriptors. If there's not enough files that can be opened, then you start losing packets. It's kind of like the open file setting on a Linux or Unix box. And that can cause packet loss. Now, with Linux, the ethtool utility, as we'll see on the next screen, is a way to adjust that. But again, these are below the NetBackup layer, but do affect the performance. So let's talk about that some more. Again, the send and receive are both involved. I only have the receive here. But one of the things that Veritas has noticed is that increasing the receive ring buffers on a server, one, is dependent upon the hardware being used. So the interface that you use may be different. So for example, on the network or the NetBackup appliances, the default setting had been 256K, and they can go as high as, or 256, and they can go as high as 4K on those settings. And for the receive side, that just essentially gives you a bigger catcher's mitt as to what you can do, or as what you can catch. For the send side, one of the things that Veritas has noticed that by increasing the send side, sometimes to the max, this is not true in all environments, and this is where tuning comes involved with what works with your environment. But sometimes creating a send buffer too big will cause what they term as jitter. Kind of makes it flaky. Again, to look at these settings on a Linux box, you can use the ethtool command as you see there. And again, just to reemphasize, I know I just touched on this, with tuning, with any tuning that you do, whether it's with the receive buffers or the ring buffers or anything, plan it out first. Know what you're implementing, and then test and repeat. And so you know the full effects of the changes that you are doing. And lots of companies now have change control, which are a great way to track what is going on and the changes that are made. But know that you may have to do try, fail, adjust to get the best performance within your network. So as one of the best practices was mentioning, bonding or teaming is a great way to get more throughput in to a backup server, or coming out of a client, whether it be a database client or a file server or a NetBackup media server. Bonding is definitely a way to increase the throughput. Now, there are different kinds of bonds configurations, and it's best to know what strategy is being used by the network team. And in some cases, bonding, though you may, as a whole, increase the throughput, sometimes the per connection rates remain the same. And an example being with LACP bonds, there's a pair that a source and target pairing that happens. So if your NetBackup media server is always talking to your Oracle server, it will always go over the same interface, no matter how many connections you make. So if you have 4 1 gig Ethernet connections in an LACP bond, you're never going to get more than that 1 gig performance out of those connections Now, if you have 4 different servers and they're going over 4 different NICs, then that's where the benefit comes in. So again, know what kind of bonding you're using and what kind of performance that goes a long way to getting best backups. WAN connections. Excuse me, take a sip of water. With WAN connections, a lot more companies these days are doing replications, either between data centers or, well, always between data centers, but either between data centers regionally or cross country, or sometimes even intercontinental. And a lot of times network teams have equipment in place that optimize those connections. If there's not, though, there are tools like for the NetBackup appliances. Those come with a WAN optimized kernel option that you can enable to help optimize the traffic between those replications. Now, one thing I will point out for those running NetBackup appliances version 2.6, 1.2 and earlier, you may want to check into upgrading, as the kernels that are now being provided for the 2.7 release and above are a newer kernel. They're from a different company and perform a lot better. Now, what does the kernel actually do? It does a per connection optimization. So it can determine whether it needs to optimize a connection that may be going for a replication versus a connection that's going over the LAN in the same data center. The qualifications for whether it gets optimized, or when this really helps, is there latency greater than 100 milliseconds, or is there a packet loss greater than 0.01%? These are the times when the TCP fast kernel optimization greatly benefits. But again, if your network team is already doing optimization of some kind, it's best to work with them, because sometimes the two working or being both enabled can be counterproductive to good packet rates. One of the things that NetBackup has implemented a few versions ago now is something called network resiliency. And this is targeted for connections that may be slow or prone to error, if I can use that, whether it be high latency or packet loss. NetBackup has added a new process that, when enabled, will help to maintain that backup connection to a client, whether it's for a backup or a restore job. And this is just between the NetBackup media server and the client. So it will not work between a master server and a media server, or 2 media servers. But what it does help do is, if there is a broken network connection, that happens for a split second or a few seconds, it is able to recover those connections without generating an error in the backup. And again, the setting that you see on the screen is on the master server's host properties. That's where you would go to set it up. At the bottom, there will be a resilient network setting, and you just go and add in the name of the client or IP address that you want to set up that connection for. One of the things that I was mentioning earlier with multiple interfaces is routing. Now, again, routing is critical to NetBackup, and NetBackup does not keep the routing tables. Those are done at the operating system level. NetBackup years ago put in a required interface setting that would allow an operating system to route traffic over a different interface if there was some obstacle to using the routing tables to get the traffic going over the correct interface. The required interface setting has now been deprecated, and there is a preferred network setting that replaces it. If you copy down that link and go to the tech note at Veritas, that will lay out exactly what the preferred network setting does and best practices for it. But to quote that top tech note, the preferred network option is not needed in an environment if NetBackup is configured with appropriate host names. The operating system must resolve to the correct IP address and then route the addresses correctly. However, if there is an issue with that, then the preferred network setting can be used. Now, it doesn't change the IP address being used. It will tell it to go out interface B versus interface A. Now, if there's no route to the client over interface B and you're telling it to go, there will still be an error. So again, these two tech notes that you see are great references for this setting should you need it, but with correct host files, you shouldn't need it. Performance considerations. Now, a lot of these are network related, and some of them may not appear to be network related, but the performance of the servers always impacts how fast it can send and receive data. Because if the server is CPU bound or memory bound, then it slows down even the network traffic. So what are some performance considerations from the NetBackup side, from the master media side? What is the backup window? Or do you have multiple backup windows? How many jobs are running? The fewer the better. If you can run your backups with 1,000 jobs, if you have a large environment, a night, versus 5,000 jobs, that one can make the per connection faster, but it also decreases the load typically on either the master server, media server, or client. Again, how fast are the networks? How much disk space do you have? Is virus checking enabled? That's one thing that has a tendency to kill network connections, especially historically speaking. The McAfee endpoint protection suite was known for killing network connections if it wasn't configured correctly. So know what's going on the servers, and how to tune them will greatly impact the rate at which those backups can be done. And then from the client side, a lot of these are the same. What's your backup window? Is maintenance running? At the same time that you're trying to do backups. This can be true for databases. A lot of times, DBAs will run their maintenance, in the middle of the night when the databases are not being used as heavily by their users. But it can create a load on the database server such that it impacts the backups. So knowing your backup windows and what's running on the clients can help greatly with getting the best performance out of your backup environment. Now, these are common status codes that we see for network-related errors. I make this reference here that Veritas does publish a document for each version of NetBackup with all the status codes in it. And they have troubleshooting steps that you can do to help resolve those issues. We're not going to cover all of those here. We don't have the time. But again, we're just going to highlight some of the errors and some of the more common resolutions. Typical network errors include a status 24, a socket write failed. Excuse me. I like to term it, hey, where did my network connection go? And you'll see why in just a minute. Status 25 cannot connect on socket. This typically indicates a process timed out. Either there was a block in the network so that the packets couldn't get through, or maybe the NetBackup client services were not listening or not running to receive those. Now, a status 26, on the other hand, is that the client received the packet, but in that initial handshaking where they're setting up the connection, something happened. Sometimes it could be that the service crashed or is hung, or maybe the root file system is full and it's run, it can't open files or something like that. But a 26 is different from a 25 in that the connection initially made it, but then something happened. Status 40, network connection broken. The connection between the client and the server was broken, or between the master and the media server. It could be that something happened again to the road, to the network path. Maybe there was an accident in the road, to use that analogy. So pinging the target to make sure that there is that path is still existing is a typical method to troubleshooting a status 40. It might be good for the others as well. A status 41 is a network connection timed out. Typically, in this case, the NetBackup processes were waiting for data to come from the client, and after a set period of time, it did not receive any data, and so it terminated the connection. From the server side, there's the client read timeout, but that can also be set on the client side depending upon where the connection is being initiated from. The client read timeout, again, can help overcome those, but all it does is allow NetBackup a larger window to receive that data. It won't actually make it come any faster. Status code 42 is a network read failed. This is very similar to the 24. Sometimes we see this more on the server side when there is a 24 on the client side. And we'll get into that a little bit more again shortly. Status 47 is the host is unreachable. Typically these come from application state captures where the media server couldn't contact the NetBackup client on the virtual machine, either because of hostname resolution or maybe because the NetBackup client services on the virtual machine aren't authorized. The media server is not authorized to access that. Those are two things to check for that. A status 48, client hostname could not be found. Again, that's typically a name resolution issue, and we need to make sure that name resolution is working, whether that's DNS or whether that's host files. I will add in here, when you are working with hostname resolution issues, there's a BP client command that you can run, BP CLNT CMD -clear_host_cache to tell NetBackup to refresh its host cache. But you may also need, at the operating system level, to refresh the host cache or the DNS cache at the operating system level as well to make sure everything is flushed to get that new name resolution working correctly. To go back to the status 24 or 42 errors, and again, I'm going to sidestep just for the moment. If you do have questions, go ahead and ask them online, and we will try to get them answered as much as we can online, but know that we may need to research some of them, or it may take more time than just being able to answer it in this session, and that we will get back to you. But to jump back in, going back to our network or layer diagram with the NetBackup application and operating system, to use this diagram, a 24 or 42 is when the socket is lost from the NetBackup perspective. Now, where it's lost can be any one of these places that you see circled. It could be the operating system, the device driver, the NIC cable, something in the network, and then again on the client side, it could be the operating system, device driver, or NIC. A loss of connection anywhere in those layers will result in a 24 error in NetBackup. And then the key is identifying where in that process that error happened. But again, it's outside the realm of the NetBackup application. What are the most common reasons for a status 24 or 42 error? A lot of times a new NIC gets installed, or the NIC firmware is updated, or there's an OS update that updates a device driver. Any of those things can impact the network connection. So it's good with proper change control to know what is happening in your environment. And that's where teamwork comes in, because not all of it's under your control, especially if there's a separate server team that's involved. The TCP chimney off-host feature, especially for Windows clients, but not limited to Windows clients, is a feature that can get enabled, which does help with performance, but there have been bugs within the coding of that process, which results in packets being dropped. So a typical step, if TCP chimney is enabled on a client or on a media server, is to disable that and run the backups and see if that resolves the issue. If that is a feature that is required for whatever application that you are running at the server level, then maybe stepping back a driver version might be the right answer, or dropping back the firmware version that was just updated might be the answer. Sometimes updates like that will enable the TCP stack. So what you think you've already addressed because of an update may be re-enabled, so it would be good to go back and check that. As I mentioned before, McAfee and some of the other endpoint protection applications may terminate, especially if they're monitoring the network. The backup traffic patterns are not typical patterns that those are set up for, unless you're running like a Symantec endpoint protection. But is an endpoint protection application terminating the socket? And then securing the TCP stack or over-tuning can also result in the OS killing the network connection. Some of the things, or as an example I should say, is like denial of service, like on an Active Directory server or an Exchange server or something like that. Sometimes the servers are tuned so tightly at the TCP level that it causes problems with the backups. So knowing those settings can go a long way. And then a client CPU or memory being maxed out, faulty network cable, or firewall in the middle can also cause that connection to be broken. Now, being in the middle, it could either be in that mysterious network cloud that we were talking about earlier, or it could be a firewall on the server or the client. So I'll kind of cover these quickly, but these, again, are for reference. These are tools that you can use to help identify when there is an issue, to know what kind of throughput you are getting, to help maintain that ideal backup environment or network environment. Again, because most of the time, the backup admin has little or no view into the network health without engaging the network admin. So I'm going to cover briefly the BP testnet con, the BP test BPCD and the NBPerf check commands that come with NetBackup, either on the server side or also on the client side. Then there are tools that are available with the operating system. Most operating systems, I think all operating systems nowadays, have NetStat, ETH tool for Linux, TCP dump, or Snoop for looking at the NetBackup or looking at the network traffic. Then there's system reporting utilities like SAR or Performance Monitor that keep track of network errors and things like that. Other tools are SMB or CIF share file transfers. That's an easy thing to do to test whether we're dealing with a NetBackup issue or not, or FTP or SFTP as well. And then for third-party applications like Wireshark or iperf, those are available as well. So let's run through these real quick. The BP TestNet Con is great when you're trying to troubleshoot a preferred network directive. It will show you forward and reverse lookups and the speed that it can do that, and with the preferred network, which interface it would be going over. It can also check connections to like the EMM server or the NBSL process if those are in question. There are a number of different tech notes available from Veritas. Those are a couple of the numbers that you can use. But this is a tool that's both on the server side and on the client side for NetBackup. BP Test BPCD is another utility, just to make sure that that connection is happening. If you're getting a 25 or if you're getting a 26, this is a great tool to see, is the client responding, especially if you don't have the ability to log into that client to check it because of division within the company. This is something, again, that is available on the NetBackup server side, but not on the client side. NBPerf check is a great way to test performance. It started out originally for the server side to test disk performance, disk read and write performance, but can also be used between NetBackup media servers to test the network connection. Now, you can't do this to the client, but between media servers, you can test the performance of a connection using the NBPerf check command. NetStat is great and has a ton of information. I can't cover it in depth by any means today, but there are things like packet retransmissions. Are there a lot of packets that are getting retransmitted? That will show congestion on the network. Is a process listening on the port, on a port? You can get that from NetStat-A. Again, take note of what options are here so that you can use them. You don't necessarily have to learn everything about them, but will definitely help. Here's some more NetStat statistics. How many packets are being dropped? Besides retransmissions, packet drop does cause problems. Is it because of a socket overrun, which we've covered briefly before, but these are things to look at as indicators to the health of your network. That may indicate what steps need to be done before. Now, this is ETH tool. I mentioned it briefly for the ring buffer size, but there's also flow control settings or flow control counters that can be used if you're troubleshooting a poor connection. Whether the media server is being told to slow down because it's sending data too fast, or if it's being told to slow down, or if it's telling the client to slow down because it can't process fast enough. Flow control stats should be 0, and if they're not, that would be a good indicator that something definitely needs to be looked at. Now, TCP dump, most of us in the backup world don't get into this level of troubleshooting, but here are a couple of filters that you can plug in to TCP dump real quick to see, if a connection is being broken, if you are troubleshooting status 24, where is the reset coming from? And that will give you an idea of where to look. And you'll see how to use those right here. Again, you don't have to know everything about it, but having these will help identify when there is a problem. And TCP dump is essentially equivalent to Wireshark. So if you are running Wireshark, if your network team is running Wireshark on a server, or will load it on a server for you, you can use the same flags and filters for TCP dump in Wireshark as well. And this is just an example of that. SAR, or Performance Monitor, which we'll get into in a moment, is a good way to monitor over time, especially if you're trying to monitor over the weekend and you're not there to keep track of every little thing that's happening. SAR or Performance Monitor are good ways to track when errors happen. Specifically for SAR and network errors, there's an EDEV flag that you can use to highlight just those specific counters. And then there's also a utility that I like to use called KSAR, which is free. You can find it on the internet. It's been around for a number of years, and that will graph the SAR data to something like this. And then you can see those trends over time, because when you're looking at numbers, you may not be able to see the trends, but if you're able to graphic like with KSAR, that can definitely aid in troubleshooting. Again, for Performance Monitor, there may be a way to graph performance data. You can set up the kernel parameters so you can go into, so you can graph that within Windows, but that is a subset of the Performance Monitor. You can set this up on a schedule, and to find out more about it, I would go to the Microsoft site. But again, it shows the connection errors, so you can keep track within a certain period of time how many errors are and what kinds of errors are happening to help better troubleshoot. iperf is a framework or utility in this case that many storage vendors like to implement for testing performance to their storage servers. Many Linux operating systems come with it. The appliances from NetBackup do not, though it still can be used. As the examples here show, you can run iperf between two clients to test what kind of performance that you are getting. On the Windows side, there's different freeware versions of iperf. There's also graphical ones like jperf that I found while doing this presentation or preparing for it that you can implement. Sometimes you can get these installed if on a client without having to get the network team involved, as a way of gathering information that you can then take to the network team saying, hey, we're getting this kind of performance outside of NetBackup over these interfaces, and it's resulting in poor performance at the backup level. What can we do? How can we work together to get that resolved? If you're not able to load an application like iperf or Wireshark on a client, then something that you might be able to do is to do like a CIF share transfer or an FTP transfer. On the right, the FTP utility that I used is WinSCP. There's FileZilla and other utilities that do the same thing, but both of these utilities are good for testing the network connections between two servers outside the framework of NetBackup to identify where the issue is and what kind of rate you are getting as well. With Windows 2012 and newer, as you see on the left, Microsoft gives you that performance graph rather than just progress, so you know what kind of rates you are getting. And then final thoughts. NetBackup again relies heavily on networking. You know, they go hand in hand. If you don't have a network that works, you know, or is having issues, NetBackup is going to feel that. It may not be the source of that pain, but it will definitely report that pain in the form of failed jobs or very poor performance. And again, NetBackup is the most robust network analysis tool you will find, in our opinion, because of the volume of traffic and the communication that is required of it to perform its job. So again, it's very quick to find out, is there a problem in the network? Now, sometimes it can be adjusted within the NetBackup framework. Sometimes it has to be adjusted outside of the NetBackup framework, but these tools that we've covered are ways to identify where we need to focus to get the problem resolved. Things to ask before is, has this worked before? If it's no, then we need to check configurations. You know, it could be something within NetBackup. It could be a hostname resolution error issue. It could be a routing issue. It could be any number of things. But if the answer is yes, then the question is, NetBackup was configured correctly. Well, what has changed? Was it something within NetBackup, or was it something outside of NetBackup? Was it the operating system? Was it a NIC? Was it, you know, a network cable? Was it the switch? Was anything of those updated in any way? You know, these are all questions that we need to ask. And as always, Veritas does have a variety of best practice guides and manuals and patches that are available. Google searches or Bing searches or whatever search engine you use are a great way of identifying either issues that you're having or guides that you may not necessarily keep handy all the time. So that can be a good tool as well to use. So again, you know, if you have any questions that you haven't asked already, feel free to ask. I don't know if we'll be able to answer because of the time or me answer them, but hopefully Chet and Brad have been able to answer them for you. But if you do have questions, let us know. If there have been questions that haven't been answered, we will get them answered for you. It may not be in the next, you know, hour or so, depending upon how much research needs to be done or where that answer needs to come from, but we will help get those answered for you. And the presentation will be online, hopefully soon. The link that you see there is where you should be able to find it. And we thank you for attending today's presentation. And with that, I'll turn it back to Danielle.
Thanks, Paul. Thank you, everyone, for attending today's webcast. As Paul mentioned, an on-demand version will be available within 2 to 3 days, and you will receive an email notification once the recording is available. Thank you again for participating in today's webcast.